Okay, this is part 3. I accidentally cut off the video from part 2. So let's continue on filling in this table of values. I will now put in x equals -1 into the quadratic equation. -2 times -1 squared plus 3 times -1 minus 1. This is 1, so it's -2 times 1, which is -2, minus 3 minus 1. That's -5 minus 1, which is -6. When I put -1 into the equation, I get -6. When I put 0 into the function, I get -1. 0 squared times -2 is 0. So that's 0. Plus 3 times 0 is 0, so I get -1. You try it. Now, the fraction, -2 times 1/2 squared plus 3 times 1/2 minus 1. If I square 1/2, that's the same thing as 1/2 times 1/2. That gives me 1/4. So -2 times 1/4 plus 3/2. 3 times 1 is 3 over 2 minus 1. Well, that's equal to -2/4 plus 3/2 minus 1. Well, that's equal to, that's -1/2 plus 3/2 minus 1. Well, 1/2 minus plus 3/2 is 2 over 2. This is a 2 over 2, which is 1, so this is 0. When I put 1 into the function, I get -2 times 1 squared plus 3 times 1 minus 1. That's -2 times 1 is -2 plus 3 minus 1. -2 plus 3 is 1 minus, wait a second, that's also 0. That doesn't seem right. Well, I had to double check my math. It is correct. Interestingly enough, the axis of symmetry is at 3/4, and so you can have these two mirrored points. So I bet some of you had a few minutes of doubt on if that was the correct answer, but it is. Now I'm going to put 2 into the function, -2 times 2 squared plus 3 times 2 minus 1. I'm putting out 2 into the function. That's 2 squared is 4. 4 times -2 is -8. Plus 6 minus 1, so it's plus 6 minus 1. -8 plus 6 is -2 minus 1, that's -3. Okay. For 12, how many solutions does each parabola have? Okay, let's look at the graph, and how many times does it cross the x-axis? Remember, solutions are the x-intercepts. This has no x-intercepts. It does not ever cross the x-axis, so it's 0, or no real solutions. This parabola crosses the x-axis twice, so there's 2 there, 2 solutions. Here, it touches the x-axis once, so there's 1 solution. And here you can see the parabola, even though it's going up, it most certainly crosses the x-axis in 2 places. So number 13 is graphing to solve. And in order to graph this, I'll need to find the axis of symmetry and vertex and y-intercept and additional points again, because this is not factorable. It is not factorable. We're asked to graph it to solve, but if I try to make a diamond here to solve this by factoring, which would be much easier than graphing, I get -1 times -2 is 2, and a +6 for the bottom of the diamond. And there are not two numbers that multiply to 2, but add to 6. You can try, but you won't come up with any. So we'll use our method of finding the axis of symmetry. X equals the opposite of b over 2a. The opposite of b is -6. 2 times -1 is the bottom. 2 times a, and a is negative 1. So that's negative 6 over negative 2, and so our axis of symmetry is at 3. I should say the equation for it is x equals 3. There's the equation for the axis of symmetry, and we can put that on the graph. X equals 3. Now the vertex is found by putting that value of x into the function. The opposite of 3 squared plus 6 times 3 minus 2. Let's see what we get back out. 3 squared is 9, so that's negative 9, plus 18 minus 2. Negative 9 plus 18 is 9. 9 minus 2 is 7. So the vertex is going to be at 3, that's the x value, 7. And it's going to be on this axis of symmetry. 1, 2, 3, 4, 5, 6, 7. There's the vertex right up there. That's pretty high up for the vertex. I'm assuming now, I'm thinking it's a maximum, which it is because this parabola opens downward. The a is negative. The coefficient of x squared is negative. So this parabola is going to open down. On the right track here. Our axis of symmetry is x equals 3, and the vertex is at 3, 7. Now the y-intercept is the c value. So the y-intercept is negative 2. And we can plot that right there on our graph, and we can reflect it 1, 2, 3, 1, 2, 3 across the x-axis, or the axis of symmetry, excuse me. Now we have 3 points. We need to plot additional points so we can get a really good sketch of this parabola. Well, I can see that 2 could be used as an x value. I don't have a point there on that line. Or I could use 1, or I could use 1, 2, 3, 4, or I could use 5, right? If it helps you to number, then go ahead and number your coordinate graph here. I'm going to put in 1. No, I'm going to put in 2. I'm going to put in 2, because if I put in 1, I'm afraid it might be down here somewhere. And if it is, it's not going to help me get across that x-axis like I'd like. So I'm going to choose 2. So the additional point here is going to be when x equals 2. Let's put it into the function. The opposite of 2 squared plus 6 times 2 minus 2. What is that going to be? Well, 2 squared is 4, so that's minus 4. Remember that negative is on the outside, so it's minus 4 plus 12 minus 2. So minus 4 plus 12 is 8. 8 minus 2 is 6. So my additional point is going to be 2. X is 2, and the y value that comes out of the function is 6. So now I can plot that point 2, 1, 2, 3, 4, 5, 6. And I can mirror that point 2 across here to over here. So that's the mirrored point. That's the one that's reflected. Now I'm going to carefully draw the curve. Actually, 1 might have been a better choice now that I look at the graph. It might have brought me closer to the solution here. But I'm going to draw this graph like that. The best that I can, I'm going to draw this curve the very best that I can, so that I can see where does this parabola cross the x-axis. Now, if I did it as accurately as I can, it looks to me like x is between, let me put it this way, the x-intercepts right here and right here, those x-intercepts, it looks like they happen between 0 and 1, so between 0 and 1, and it looks like they happen, the x-intercept happens between 5 and 6. So it crosses the graph here between 5 and 6. Those will be our solutions. Some number in between 0 and 1 and some number in between 5 and 6. Okay. Well, I hope you got some help from this, and I'll see you tomorrow.